Now there are some sort of, the transition metals can form ions of varying charges. And here we have some. We have chromium with, could be 2 or 3. Let me change this now. Chromium can be 2 and 3. Copper can be 1 or 2. Gold can be 1 or 3. Iron can be 2 or 3. Lead can be 2 or 4. Silver can be 2 or 4. So we have to have a way of distinguishing these ions when they're in compounds. You should find this on page 135 in the text. So this is how we can name. One system says we can use a Roman numeral to indicate the charge, so that when we write the name, we could say chromium 3 or chromium 2. Now we only use these Roman numerals when we write the name in words. We never put Roman numerals inside our formula. Now the old system uses the suffix OUS and IC to indicate which is the higher or the lower charge. IC always means the higher. OUS always means the lower. Now IC doesn't necessarily mean 3. It does for chromium, but you notice it wouldn't for lead. Lead being +4 and +2. So let's look at some other ones then. So copper could be copper 1 or 2, or cuprous and cupric. Gold, gold 1 or gold 3, auris or auric. Iron 2, iron 3, ferrous or ferric. Lead 2 or lead 4, plumbous, plumbic. And lastly, tin 2 or tin 4, stannous and stannic. Now here's a periodic table of these ions. So again, you get a better feel for where they're located. Now I want you to notice that there are some, in my arrow again, there are some transition metals that only form an ion of one charge, like the zinc and the silver and the cadmium. So you would not have a Roman numeral indicating the charge if you were to write the name for compound. So if you're writing the compound, the formula for, like, say, silver chloride, you see how it's +1 and -1? The formula would be just AgCl. But if you were writing in words, you write silver and then you write chloride. You wouldn't put in silver Roman numeral 1. So only the Roman numerals if you have charges that can be different for that element. And it's only for the positive ion. Okay. So here's one for you to try. What are the formulas for chromium 3 nitride and gold 3 bromide? So what we need to do is come up with the ions for both. So chromium 3 and chromium 2 and gold 3 you could get just by looking at the Roman numerals. Nitride and bromide, you might want to check your periodic table. So I'm going to start you off with this one. This is chromium 2 nitride, and this is what the ions would be. So why don't you try to come up with the formula on your own, and then we'll see if you got it right. Okay, here's the answer. We need 3 chromiums and 2 nitrides to give a total charge of 0, and then we get Cr3N2. And you notice you could have just taken the 2 and switch it, and 3 and switch it, come up with that as well. Next we have gold 3 bromide, so that's going to be Au +3 and Br minus. So what will the formula be here? We need 1 gold and 3 bromide to give us a charge of 0, so the formula AuBr3. So you notice the names now. AuBr3 was saying gold 3 because there's also a gold 1 out there. Now what if you were given the names, and given the formulas that is, and asked to come up with the names? I just want to show you how to do this, even though I'm not going to ask you to do this on an exam. So let's say we have FeCl2 and FeCl3. Well, we're going to have to find the Roman numeral that goes with the iron. Now we know that Cl is -1, so we could figure that out pretty easily. We're going to do both at the same time so you can compare them. So we start off with our formulas. So what I'm doing is I'm going to replace the symbol Cl with its charge. So it says Cl is -1, and there are 2 of them. I'm going to put an X in for the iron. So we have X plus 2 times -1 is 0. X minus 2 is 0. X equals 2. So that means that there's a 2 on the iron for a charge. And we'll do the same thing over here, FeCl3. 3 times -1, guess that's X minus 3 is 0. X is +3. So then this would be iron Roman numeral 2 chloride and iron Roman numeral 3 chloride. Now if you just said iron chloride, it would be wrong because there can be 2 different forms of it. I want you to try this one. What is the name of PbO? And O is -2 in a compound. So what's the charge on the Pb, and then what's the name? So the x -2 is 0, x is +2, and the name then would be lead Roman numeral 2 oxide. Polyatomic ions are a group of atoms that act as one unit and they have a charge. And here are some examples. We have ammonium has the formula NH4, that means one nitrogen atom bonded to 4 hydrogen atoms. And overall the charge is +1. This all acts like one unit. Over here we have hydroxide. It's composed of 1 oxygen and 2 hydrogen atoms bonded together. Overall a charge of -1. Here we have two that are very common, also very close in formula. NO3-, which is nitrate, NO2-, which is nitrite. Now the 8 and the ite indicate oxygen is present. 8 usually means the most, and ite means the lesser, and it's usually less by 1. We have carbonates and phosphates, again very common substances. CO3, charge of -2, PO4, charge of -3. Hydrogen carbonate, also called bicarbonate, like in baking soda. It contains 5 atoms, hydrogen, carbon, and 3 oxygen atoms, all acting as one unit, charge of -1. And here are some examples you might have at home, like plaster molding. Plaster is CaSO4, that Ca is calcium, and SO4 is a polyatomic ion called sulfate. So that's calcium sulfate. And here we have a bottle of a liquid fertilizer, which is really water with different compounds dissolved in it. And that contains sodium, and this is NO3 or nitrate, so that's sodium nitrate. And we can see down here at the bottom what these things are pictured to look like. Now, if you go to page 138, you should see this chart. Do you have to memorize the chart? No, you don't. But you want to be able to refer back to it if you need it. So, and they have blocked off the ones that are most common. So we have, you notice, nitrate NO3, 8 nitrate, as I mentioned earlier. You want to go down the list and notice like we have carbonates I mentioned, and sulfate, phosphate. Here's one, cyanide, Cn-. You get acetate, all the atoms in it, charge of -1. But what about writing formulas with these polyatomic ions? We're going to follow the same rule. We want to use the smallest number of each type of ion, so the total charge adds up to 0. Here's the difference. If we need more than one polyatomic ion, we're going to have to put it in parentheses and the subscript outside. So my example would be combining ammonium and oxide ions. Now you notice the charges. The charges are +1 and -2. So we need a +2 to balance off the -2. So the formula, now we put parentheses around the NH4 because we're using 2 of them, and we put the 2 outside. Remember, again, positive then negative. And so the name is just going to be ammonium oxide. I didn't have the name written down here for you. The name is just the name of the ions. Again, we're not saying that subscript 2. Okay. Now, why don't we stop here and see if you can write the formulas for these 3. So write them on a piece of paper, and then we come back and check them. Okay, here are the answers. Sodium phosphate would need 3 sodiums and 1 phosphate, formula Na3PO4. Magnesium nitrate is going to need 1 magnesium and 2 nitrates, Mg parentheses NO3 parentheses 2. So you notice that we needed parentheses around the nitrate because we have 2 of them, but there's no parentheses around the phosphate because there's only 1 of them being used. And the last one, you notice that we're going to switch these numbers, so the 3 will wind up down here, and the 2 is going to wind up down there, and so we wind up with Al2 parentheses SO4 parentheses 3. The name, you notice, does not mention the 2 and the 3. Now this is on page 137. You see a list of common compounds that have polyatomic ions in them, and you might recognize these, some of them anyway. Let's see the first one, barium sulfate. If you ever had a GI series in a hospital, this is what you're drinking. You drink about 1 or 2 liters of this stuff. Looks kind of chalky. I think they flavored it though. Calcium carbonate is an antacid like in Tums or Rolaids. Calcium phosphate. People that have a low calcium might have to take some of this. Calcium sulfite preservative. Sulfate plaster cast. Silver nitrate, topical anti-infective. Silver can act like poison sometimes, and nitrate again can oxidize things. Some antacids, and you can look at the rest of those. And that's it for the slideshow.